స్టార్ట్ చేద్దామండి. ఓకే, సో ఈ ఆక్టేవ్ అనేది ఫ్రీ వర్షన్ ఫర్ MATLAB and you can get it on internet for free. మీరు if you search for Octave, you get this GNU Octave. And in this GNU Octave, you can download for various platforms. Like it is available for Linux, Mac OS, BSD, Windows, and you can also have so these are the download links for Windows installations, Windows operating system. And on Linux, you can directly install from command prompt. So basically, I'm dealing with Windows users. So you can download it from here and install. Okay, and a mobile application is also available for that, Android app. So mobile application is also available. It is a paid version. I mean, a one-time payment. It is for 180 rupees. Octave for Android. And most important is, I mean, some of the commands are not working on this mobile application that we need to see. Okay. And coming to Windows version of Octave. So once you install that, you'll see two options on the desktop: GNU Octave CLI, command line interface, and another one is GNU Octave GUI, graphical user interface. And I prefer to use this GUI. So click on that GNU Octave GUI. GNU Octave GUI. GNU Octave GUI. So you'll have this graphical user interface. With different tabs for file browser, workspace, command history, command window, editor, documentation, variable editor. So everything packed into a single frame. Okay, so MATLAB compared to other programming languages. So I'll start with a basic introduction to programming languages and continue into this MATLAB. Okay, So basically, programming languages, the first generation programming languages are called machine languages. Okay, so machine language is actually in binary code. So all the instructions that are understandable to computer are binary, right? So this machine language programs are also written in binary language, and next generation programs were low-level languages. These low-level languages require interpreters. So the interpreter convert whatever that low-level language into binary code. So the things that we use in 8085 is a low-level language. Okay, so that we require a interpreter to convert that low-level language code. So it is a hexadecimal code that we use to program 8085 processor, microprocessor. So that hexadecimal code will be converted to binary code. For that, we require an interpreter. And next level is high-level languages. This C, Java, and all. They require a compiler. So the program code is human readable, and people can understand those codes. And a compiler is required to convert those codes into binary. So there also you get an executable file to run the program. So all the instructions will be converted to binary code using a compiler. So for all low-level languages, we require an interpreter, whereas for high-level language like C, Java, and all, we require a compiler. So the compiler converts these human-readable language instructions into binary code. So ultimately, we get an executable file to run the program. Okay, whereas this MATLAB is even more sophisticated. We don't need any interpreter or compiler. It will directly interact with devices. It will whatever instructions given in this environment will be directly executed. So everything is packed into this package. So we don't need any compiler, and we don't come across any binary files. So all the instructions will be directly executed within the environment. So it can directly interact with devices. It can directly give you output. So that is the primary advantage with MATLAB. So it can be integrated with any device. So the coming to scientific community, there are two softwares. One is LabVIEW, that is most familiar to experimentalists. So LabVIEW is a software that gives computer control to all machinery in the laboratory. You can control any device using LabVIEW interface. Right, that is one of the most sophisticated softwares to automate the lab machinery. So you can program the machinery like running a furnace or running a fan, turning off and turning on. So all these activities, whatever machines you use in your laboratory, can be directly programmed and automated using LabVIEW. So that is worldwide accepted software. And next to that is MATLAB. So the advantage with MATLAB is you have everything packed in here. You can draw graphs. You can interact with systems. So this MATLAB includes Simulink. Simulink is a graphical user interface to deal with machines. So the machine interfacing is done with Simulink. And coming to Octave, Octave is a free version for MATLAB developed by GNU. So it is a open source software. You can even access the source code for this Octave. So these MATLAB and Octave are basically written in C language. So instructions are more similar to C language. Like all basic C commands will work in here. So those who know C language, with simple modifications, I mean there will be small tweaks, small modifications to the syntax. I can use all the syntaxes of C language in MATLAB directly. And apart from that, there are so many built-in functions. So you can use all of them directly without any trouble. So with that introduction, we'll go into the usage of this. Okay, so once you open this Octave, you'll say a window like this. This Octave or MATLAB is basically a short acronym for Matrix Laboratory. MATLAB stands for Matrix Laboratory. So whatever data you are processing herein is considered as a matrix. Even if you enter a single number, it is considered as a matrix. And for Windows 11 users, you need to, I mean, you can't see a scroll button here. Let's say just type in help plot. You get some data, but you won't see any scroll button here. There's a lot of data generated, but you're not able to scroll it. Exclusively for Windows 11 users, you need to change a setting. Okay, so for that, open your settings. Open settings. Settings, system. Settings, system, and in system you'll see for developers. For developers. And for developers, select terminal. And you have to choose window console host. So once you select that and close the settings, and you have to close Octave and open it again. Close Octave GUI and open again. So then your settings will be activated. So if you open Octave GUI now, now you are able to see a scroll button. In the command window. Okay, so with that, I'm starting this. So Octave or MATLAB. So in MATLAB, every variable that you are going to deal with is considered as a matrix. Even a single number is considered as a 1 by 1 matrix. And most important, MATLAB is case sensitive. So whatever instructions you enter, you must be careful in maintaining small letters or capital letters. So they are different. Let's say if you say x is equal to 1, just type in x is equal to 1 and enter. X is equal to 1. Enter x is equal to 1 in command window. So whatever instruction you give, it will be executed directly and you can see the result. సో ఈ మొత్తం మనం ఎక్కడ చేస్తున్నామంటే ఆక్టేవ్ GUI అనేది ఓపెన్ చేసి అందులో చేస్తున్నాం మనం. సో యు ఆర్ వర్కింగ్ ఆన్ ఆక్టేవ్ GUI. Open Octave GUI, there in command window, enter x is equal to 1. So you'll see the result also, x is equal to 1, and enter capital X. Sorry, just x, small x. Enter small x again. So the result of the variable will be displayed again. Whatever the value stored in that variable x is displayed again. X is equal to 1. So you'll see 3 more things here. In the command history pane, you'll see whatever commands we have entered. I have entered x is equal to 1 and then I have entered x. The list of commands you have entered will be visible here. And in the workspace, the list of variables introduced or defined will be stored here. So there is a variable answer, which is a 1 by 1 matrix. There are no values stored in, 0 value. And there is a variable x, double precision variable. So it can take values up to 16 decimal points. It is a double precision variable. It is a 1 by 1 matrix. And the value stored here is 1. Okay. So this is a workspace. So whatever variables you are dealing with will be visible here in workspace. Or whatever commands you have entered will be visible in command history. So right now I'm working in command window. I've entered x is equal to 1 and I entered x again. So the value stored in x, the variable x, is displayed here. Next one, I'm entering capital X. I mean, just to know whether it is same or not. So it is saying undefined. Capital X is undefined. That means what? It is case sensitive. If you change the case from small to capital, the variable is unknown. So you must be careful while defining the variables. It is case sensitive. Small letters and capital letters are different. So if you enter small x, it is giving you the result. So now I'm going to define the matrices. So how to define a matrix? Let's say I want to define a row matrix with 4 elements. So I define it as x is equal to 1 space 2 space 3 space 4 in square brackets. Square brackets 1 2 3 4 separated by a space. X is equal to 1 2 3 4. So don't change any variable names. We are going to use the same names further. Small x is equal to square brackets 1 2 3 4 separated by space. Each number is separated by a space. So what are other separating variables possible? We'll see. Try one. Y is equal to 1 comma 2 comma 3 comma 4 in square brackets. Y is equal to 1 comma 2 comma 3 comma 4. So it is 1 2 3 4. Just type in size of x. Size round brackets x. So it is a 1 by 4 matrix. Contains 1 row and 4 columns. The same way, size of y 1 by 4. So if you don't get 1 by 4 here, check whether you have given spaces or comma separating symbols. The variables are not separated. It will be considered as a single number. So by any chance, if you get size of x is 1 by 1, we have to enter x is equal to square brackets 1 space 2 space 3 space 4. Okay, it is a 1 by 4 matrix. X is equal to 1 square brackets 1 space 2 space 3 space 4. It is a 1 by 4 matrix. So comma and space are used to separate variables in a row. Okay. So now try this. Z is equal to 1 semicolon 2 semicolon 3 semicolon 4. Z is equal to 1 semicolon 2 semicolon 3 semicolon 4. Now you'll get a column matrix. That is a column matrix. So semicolon is used to separate elements in a given column. Semicolon is used to separate elements in a given column, or it is used to separate different rows in a column. So now I want a 2 by 2 matrix. Like I want 1 2 in one row, 3 4 in second row. My first row should have 1 2 numbers. Second row should have 3 4 numbers. And I want to store it in a variable p. How to enter that? This matrix P should have 4 numbers, 1 2 3 4. 1 2 should be in row 1, 3 4 should be in row 2. How to manage that? So 1 2 are in a row. Space is a separator used in a row. Then I use a semicolon and then 3 space 4. 1 2 3 4. Enter. So the row elements 1 2 are in first row. Then I use a semicolon. So first row ends over there. Then the rest of the elements will come in the next row. 3 4. Okay, so now I got a 2 by 2 matrix. You can check it size of P. That use round bracket. Size of P is now a 2 by 2 matrix. P is a 2 by 2 matrix. Then define another matrix Q with variables. It is also a 2 by 2 matrix with variables 5 6 and 7 8. So 5 space 6 square brackets semicolon 7 space 8. Small q. So I'm defining I defined two matrices P and Q. P carries 1 2 3 4, a 2 by 2 matrix. Q carries 5 6 7 8. That's also a 2 by 2 matrix. So now I want to add these two matrices. So addition operation, simply P plus Q. So 1 2 3 4 added to 5 6 7 8. Element wise addition. 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 10, 4 plus 8 12. So P plus Q. Addition operation, and P minus Q everywhere you got minus 4 minus 4 minus 4 and minus 4. Okay, so that is a subtraction operation. Now multiplication. P star Q. Star stands for multiplication operation. P star Q. So when you multiply matrix, a row will be multiplied with the column. Right? Let's say when you multiply matrix. Okay. So when you multiply, let's say 1, 2, 3, 4. 5, 6, 7, 8. What are you doing? You are multiplying the row elements with column elements. So multiplying 1 and 5, 1 plus 5, I mean 1 into 5, then 2 into 7, 14. 1 into 5, 5, plus 2 into 7, 14, you get 19. Then 1 into 6, 6 plus 2 into 8, 16. 6 plus 16, 22. Then 3 into 5, 15, plus 4 into 7, 28. 15 plus 28, 43. Then 3, 6, 18. 4, 8, 32. 18 plus 32, 50. So this is the matrix multiplication. So your row elements will be multiplied with column elements. That is how matrix multiplication is done. Then division. P by Q. So what does it do? P by Q operation. It is actually P multiplied by inverse of Q. Inverse operation, command for inverse operation is INV. So what P by Q does is it multiplies P matrix with inverse of Q. So P by Q stands for P inverse Q. So this is called left division. There is a right division operation also. P right slash Q. So what does it do? Try this. Inverse of P multiplied by Q. The right division operation deals with inverting the first matrix. P right division Q gives you inverse P multiplied by Q. But most often, I mean, we don't need these matrix operations. Let's say I want to plot a graph of x square like a parabola for a few variables. Let's say I'm going back to the variable x again. X carries 1, 2, 3, 4, 4 variables. 1 space, 2 space, 3 space, 4. So x char is 1, 2, 3, 4. Now I want to square them. So my variable, new variable r, I'm defining r is equal to x star x. What does it give? It is giving an error. So you can't perform matrix multiplication operation because of dimensional mismatch. So when you multiply a matrix, your column index in first matrix must be same as row index in second matrix. So whatever number of columns in a first matrix must be matching with number of rows in the second matrix. Then only you are able to multiply. I mean, you can even multiply a 2 by 5 matrix. You can multiply a 2 by 5 matrix with 5 by 6 matrix. You can multiply a 2 by 5 matrix with 5 by 6 matrix. That is possible because the row count, I mean column count in the first matrix must be matching with row count in the second matrix. So here what we are expecting is I want to square each element individually. So I'm expecting a new matrix should carry 1, 4, 9 and 16. So to perform that element wise multiplication operation, we have to insert a dot. So, to get the previous command, use up arrow. Use up arrow, you'll get the previous command. So you have to use r is equal to x dot star x. X dot star x. Then it performs element wise multiplication. 1, 4, 9 and 16. Element wise multiplication. The same way you can even see the element wise division also. Let's say if you want to go for p by p, what happens? P by p is what? It multiplies the matrix P with its inverse. P multiplied by inverse of P gives you that 1001 unit matrix. Now I go for P dot slash P. So when I use dot, it takes element wise division. I get 1, 1, 1, 1. So P dot slash P takes element wise division. So when you are considering the matrices as just data elements, you have to use dot for multiplication and division operations. Addition and subtraction is fine. Addition and subtraction are element wise operations, so you don't need to worry about them. But for multiplication and division, you have to use dot when your matrices are actual data elements. Okay. So now, I mean, you can just plot, try that, plot r comma x, sorry, x comma r. You should get a parabola.
వర్క్షాప్ ఓన్లీ ఫస్ట్
plot x comma r gives you a parabola. This is not smooth because we are using very few elements, so it is not sharp. I mean, you get the sharp edges in the graph. So if you don't see your new window opened, you can always see, I mean, it might be minimized. You can check it. Sometimes the graphical window may get minimized. You just have to unminimize it. Okay. So I'm closing the graph. Now I want to see how to access individual elements in a given matrix. So let's say the matrix Y also contains 1, 2, 3, 4. Let's say Z is 1, 2, 3, 4. So I'm defining another matrix Y is equal to let's say 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. Y carries now 5 elements. And I'm defining a new matrix. S is equal to, I'm developing a random matrix, rand 3, 3. S is equal to rand 3, 3. I developed a random matrix. So now I want to access individual elements from this matrix. So let's say I want my first element at right S of 1, 1. S of 1, 1 gives me the first element of the matrix. Same way S of 2, 3. Gives me the 2 by 3 element. S of 3, 1. So you may get a different random number matrix, but the elements the elements may be different, but the positions are fixed. Let's say S of 3, 1 gives you the element stored at 3, 1 position, 0.8351. So you may get a different number, but the number at that particular location will be displayed. Okay, so now I want to access a complete row. Let's say I want to access the first row. So I have to keep a colon. S of 1, colon gives you entire first row. Same way, if you want to access entire column, colon, 2. Now I should get all rows in second column. The colon stands for all. All rows, second column. So 1139, 3154, 9954. So I got my second column. This is that. Now always second column. So if you want to access a particular portion of a matrix, let's say I want to access the first 2 by 2 portion. So what I have to do, I have to 1 to 2 rows, comma 1 to 2 columns. I get the top left corner of the matrix. So if I want to print bottom right corner, how to do that? I want to print bottom right corner. What to do? So be interactive. I get the bottom right matrix. Sometimes we may not know the size of the matrix. Like if I want to print the matrix starting from second row to the end, then S of 2 to end. Comma 2 to end. You get the same output. if you are not sure about the size of the matrix, you can directly go to the end. Two to end. Right. So if I want to print the entire matrix, so what shall I do? One possibility is I can use colon colon. My entire matrix will be printed. Another way, S of 1 to n, 1 to n. Right. So to access the entire matrix, so this 1 to end can be, in short, can be represented as simple colon. So if you just place a colon, it implies one is on the one end is on the other end. So just simple colon implies it is 1 to n. So that is how I'm able to access the entire matrix. So you can see the list of commands available for matrix operations. I'll share the PDF. MATLAB basic function reference is available. So list of MATLAB commands. You'll get from MathWorks MATLAB website itself, MATLAB basic functions reference. So it gives you all basic commands that you use in MATLAB. So whatever we have seen as of now, like plus minus star slash matrix mathematical operations, dot star and dot slash are element wise or array matrix operations, element wise matrix operations, and caret is for power. Let's say if you directly want to square the matrix, you have to use caret. Let's say we'll try that. So I'll share the link for that first of all. So the download link for that list of commands is posted in the chat box. MATLAB basic function reference. The list of commands are pasted in the chat box. You can access. So let's say if you want to have a power, what did we do? Let's say our matrix P 1, 2, 3, 4. So if you go for P, power is shift 6, caret symbol, shift 6, P square. You get matrix multiplication. P matrix is multiplied with P. And if you want element wise square, P dot caret 2. On 4, 9, 16. So element wise square, P dot caret 2. Next one, complex conjugate or transpose. So here you may need define a complex matrix. Let's say how to define a complex matrix. Let's say I'm defining T is equal to 1 plus 2i comma 3 plus 4i semicolon 5 plus 6i space 7 plus 8i. So 1 plus 2i, 3 plus 4i will be in first row, 5 plus 6i, 7 plus 8i will be in second row. So I can use comma or space to separate row elements, semicolon to separate column elements. So now P prime single quotes, the single quote symbol T prime. So it is a complex conjugate followed by transpose. So row elements are now turned into column elements, and all complex numbers have got complex conjugates. So these operations you may require in quantum mechanics, basically. So T prime stands for transpose and complex conjugate, both operations, whereas T dot prime is just transpose. T dot prime is just transpose. So CONJ of T gives you just complex conjugate. This is our matrix T, and conjugate CONJ, conjugate of T gives you just complex conjugate. We'll try that. So T dot colon is same as conjugate. So T dot double prime is same as conjugate T. Okay. So now, if you don't want to display the output, so the conjugate T is this, put a semicolon. The command will be executed, but it will not be, the output will not be displayed. Let's say define U is equal to conjugate T, put a semicolon. The command will be executed, and if you enter U, the data is stored in U, but it is not displayed. So if you use a semicolon, output will not be displayed. The command will be executed, but output will not be displayed on the screen. I mean, sometimes we don't need the output of all intermediate steps. All we need may be a final result. So in that case, you have to use semicolon for all the intermediate steps. These are the basic commands. So pi is a built-in number. So if you enter pi, you get that result, PI. And other special variables you can see I, J are used for imaginary numbers. Like instead of 1 plus 2i, I can even write 1 plus 2j. Because in electricity, we are using j instead of I for complex numbers. Because I is reserved for current. So we may use j to represent complex numbers in electricity problems. So both are reserved for complex variables, I and j. So you can get real part of the complex number separately, imaginary part of the complex number separately, real and IMAC. They are the commands to extract real part and complex part separately. And phase angle directly can be extracted. And these are exclusively developed for electricity applications, like complex numbers for electric circuit analysis. Phase angle is used over there. That will see that time. This is complex conjugate. Is real. Is real is a question whether a given matrix is real or not. So we'll try to extract those real part and imaginary part. So let's say T is our matrix, real T. Gives you real part of the matrix. Imac T gives you imaginary part of the matrix. So let's say if you write real T plus I star imaginary T. I should get my entire matrix. That should be same as your T. And what are the other commands? So these all were completed, defining the matrix and accessing individual array elements. You have 4 to colon 6 comma 2 to 5. So accessing elements in a matrix is done. So there are other ways to generate this data. Another matrix commands. Let's say you want x is equal to 1 is to 0.1 is to 10. So that 0.1 stands for the step size. 1 is to 0.1 is to 10. So it generates elements starting from 1 to 10 with a step size of 0.1. Otherwise, let's just start from 0. X is equal to 0 colon 0.1 colon 10. It generates elements starting from 0 to 10. Now you can define y is equal to x dot square.
ഇല്ല ക്ലാസ്സിലാ
ക്ലാസ്സിലല്ല
ഒന്നുമില്ല നിങ്ങൾ എമ്മണ്ണില്ല ഇല്ലല്ലോ എമ്മണ്ണിലായിരുന്നു
Get square of all the elements. Then plot x comma y. Now you get a smooth curve.
പ്രശ്നം ഉണ്ടെന്നോ?
So x is equal to, the command history, x is equal to 0, colon, 0.1, colon, 10.
ഇവിടെ
So this generates a set of numbers starting from 0 up to 10 with a step size of 0.1.
അപ്പൊ ജോലി നിർത്തിയോ? ജോലി നിർത്തി.
So y is x dot square.
അമ്മയും അച്ഛനും ഉള്ളതുകൊണ്ട് സമാധാനം ഉണ്ടാവില്ല. അമ്മയും അച്ഛന്റെ അടുത്തല്ലേ.
Way to generate data and plot. So there are some other commands also, like linspace does the same job. Linspace stands for linear space. There is another command also, log space, that gives you the set of numbers followed by logarithm. Linspace and log space. Let's say the same x can be generated by linspace. Here you have to use round brackets. Linspace 0, comma 0.1, sorry, 0.1, comma 10. The x is equal to 0, colon 0.1, colon 10 in square brackets is same as x is equal to linspace round brackets 0, comma 0.1, comma 10. So you can see that in a command history, the command that I have entered. X is equal to linspace 0, comma 0.1, comma 10. So this is the same as x is equal to square brackets 0, colon 0.1, colon 10. What is it giving? No, it's not doing that. So what is the n equally spaced values? So you have to give, so the linspace command is like this: a, b, and n stands for number of values. So number of divisions. So how to use that? Linspace x is equal to 0, comma 10, comma 1000. Is it?
1000? 0.1.
So a, comma b, comma n, number of intervals 0, comma 10, comma 1000. X is equal to linspace. Sorry, linspace. Right? So now it does the job. With a step size of 0.1, you got all the elements. X is equal to linspace 0, comma 10, comma 1000. So if you want to specify the number of elements, you should use linspace. And if you want to use the step size, you have to use like this.
എമ്മണ്ട് കഴിയില്ല. അയ്യോ ഞാൻ ഓല നോക്കലില്ല. ഞാൻ അങ്ങനെ എഴുതും, ഓല അങ്ങനെ കോപ്പി ചെയ്യും. അത്ര.
In that case, you may have to use 100 probably. Is it?
അതും മട്ടം വരക്കും. ആകെ കുറച്ച് ശ്രദ്ധിക്കണ സഹല മാത്രമേ ഉള്ളൂ. കുറച്ചൊരു ബോധമുള്ള ആള്. എന്തെങ്കിലും ഓള് ചെയ്തു നോക്കും, സ്വയം കിട്ടിയില്ലെങ്കിൽ. ആദ്യമൊക്കെ ഞാൻ ഓരോരുത്തരും പോയി നോക്കുമായിരുന്നു. അത് അന്തലാലും ആ ടീം ഉണ്ടല്ലോ, അവരൊക്കെ ഞാൻ ചെയ്തോ. ഇപ്പൊ ഞാൻ പോവൂല. നോക്കി എഴുതിക്കോ, നിങ്ങൾക്ക് എന്താ സംശയം വന്ന് ചോദിച്ചോ. ഞാൻ പറ്റാട് താന്നിട്ട് ഞാൻ അവരോട് പറഞ്ഞു ഞാൻ അത് 8ാം ക്ലാസ്സിലും 9ാം ക്ലാസ്സിലും കുട്ടികളെ പഠിപ്പിക്കണം പോലെ പഠിപ്പിക്കണം. അവനും ആ 2-3 കുട്ടികളുണ്ട് അവിടെ.
Space and log space. So this one is more convenient using the step
പേപ്പർ
size.
നോക്കിയിട്ടേ ഇല്ല. ലാബിൽ ആൽഡിയിൽ എന്റെ പേപ്പർ ഉണ്ട് C3.
Okay. Zeros generate M by N matrix. So zeros M comma N gives you a M by N matrix with 0 elements. Once M by N generates a M by N matrix with 1 element. All elements are 1. IN creates a N by N identity matrix. Diag X generates a diagonal matrix with the elements of X. Check the difference. So that command diag is used for both the operations, like to convert a vector into a matrix, a vector into a diagonal matrix, and to extract the diagonal elements into a vector. The command diag is used for both the purposes. We'll see that. Diag is used for converting a vector into a diagonal matrix. At the same time, extract the diagonal elements and store in a vector. So let's say I'm defining X again. X is equal to 1 space, 2 space, 3 space, 4. Now diag X. Generates a diagonal matrix. And I call it as Y. Let's say Y is equal to diag X. So Y carries the diagonal matrix. Now I'm defining Z is equal to diag Y. So input of the diagonal matrix. So if the input is a diagonal matrix, it generates a vector. If the input is a vector, it generates a matrix. So here X is a vector, and we gave X as input to diag. So it generated diagonal matrix. If the input to diag is a matrix, then it generates a vector. And once 3, 3, it generates a one matrix with all 1 elements. Zeros 3, 3. Generates a 3 by 3 matrix with all zeros. Then eigen 3 by 3. EIG3. I. I stands for identity matrix. Then the most important thing, eigenvalues of a matrix. Let's say I'm defining A, small a is equal to 1, 2, 3, semicolon 4, 5, 6, semicolon 7, 8, 9. EIG of A, eigenvalues of the matrix A. Otherwise, take some known matrix. Let's say 3 by 3 matrix. Eigenvalues. Okay. 1 minus 1 minus 6, minus 1 1 minus 6, minus 2 minus 2 minus 3. 1 minus 1 minus 2. So with this, so after this we'll close the session for lunch. So we'll try these eigenvalues and eigenvectors. So let's say I'm defining x is equal to, what is that matrix? 1 minus 1 minus 2, 1 minus 1 minus 2, minus 1 1 minus 2, minus 1 1 minus 2, and minus 2 minus 2 minus 3, minus 2 minus 2 minus 3. One minus 1 minus 2, minus 1 1 minus 2, minus 2 minus 2 minus 3. And take eigenvalues of x. The last number is minus 7 probably. Use up arrow and change that last element. Minus 8 1 2. So now I'm taking P square brackets P space Q is equal to EIG of X. So it generates eigenvalues and eigenvectors for the given matrix. So if I keep P and Q, two variables in square brackets, the first variable stores the eigenvectors in a row. And second variable stores the eigenvalues. So P carries the eigenvalues or eigenvectors and Q carries the eigenvectors. Eigenvalues. P eigenvalues, Q eigenvectors. Thanks. Okay. So now, yes. So what is that operation actually? Diagonalizing a matrix. So you're given a matrix P and yeah, your matrix is X and you're trying to diagonalize it. I mean, that is the most common operation in the basic quantum mechanics. So what you are doing is, so here your P is the set of eigenvectors, right? So what I'm doing here is P, I'm going for a unitary operation. P dagger X P. What do you get? It's nothing. Are you getting the diagonal matrix? It is a diagonal matrix. All the other elements are 10 power minus 15 or 16. They can be considered as zeros. So if you multiply your eigenvector matrix, so that is called a unitary operation. P dagger XP is the unitary operation where P carries the eigenvectors. So P dagger XP gives you the diagonal matrix. So this is the basic mathematical operation that we use in quantum mechanics to calculate eigenvalues and eigenvectors. So for diagonalization operation, what is it doing actually? It is calculating the eigenvectors matrix, multiplying the eigenvectors. I mean, it is performing a unitary operation. U dagger X U. That P is the unitary matrix here. It is actually diagonalization unit. That's how you perform unitary operations, so matrix diagonalization. So to generate a unitary matrix, what you have to do? I mean, unitary matrix is the matrix with eigenvectors placed in columns. So your first column is your first eigenvector. So to confirm that, what to do? I want to take the first column. How to extract first column? All elements in first column. I take the complex conjugate star x star p of all elements in first column. So then I should get my first eigenvalue. -8. So you understand that? So in the eigenvector matrix, your first column is your first eigenvector. Second column is your second eigenvector. So eigenvectors are stored in columns. This is the first eigenvector, this is second eigenvector, this is third eigenvector. And to confirm that, you may try with the second column. So in this case, you should get your second eigenvector 1. Third, so what are we doing actually? This square brackets PQ is equal to EIG of X. So here P is the eigenvector matrix and Q is the eigenvalue matrix. And let's say if you want to extract eigenvalues from Q, Q is a matrix, it's a 3 by 3 matrix. And if you just want to extract that particular diagonal elements, what to do? I tried that already. You have to use a diag Q. Let's say your P and Q, Q is this. Then diag Q extracts the diagonal elements. Keeps them in a column. See all these diagonalization operations, eigenvalue operations, I mean, they are dealing with columns, not rows. So let's say if you want it as a row, get a transpose. Let's say you can store it in another way. R is equal to diag. So like that, you can play around with matrices. So all other commands can be, I mean, all basic commands are available here. MATLAB basic function reference. So it is already shared in the chat box. MATLAB basic functions reference. The link is shared in chat box. So other mathematical functions like sin x, cos x, geometrical functions. So these things we'll see in the afternoon, and graph plotting options. So the second page we'll see in the afternoon session. So up to now we have covered the first page in basic function reference. Okay. So with that, I'm closing the session. Is there anything discuss? Any doubts or confusions? Or shall I close the session? Is that okay? Right. Thank you. So with that, I'm closing the session, and afternoon session link will be shared separately. It starts sharp by 2 o'clock. Thank you.